Hello, everyone. Hello.
Hello.
Yeah.
Hi.
Is someone speaking or?
No, bro. I don't think so.
I think everyone is on mute.
Yeah.
So, any idea what will we discuss about?
No, bro. Even I'm not sure.
Hello, everyone.
Hello.
Yes, so Shuddha has opened this meeting for us to having an open discussion. So, so the topics which we have for this one, I guess, like the KNN and naive phase, which we were discussing in the WhatsApp group. So anyone can go ahead and like give some introductory things, and post then we can like discuss on as per our understanding. Like, we can then pick up first of all, like we need to understand at what level we all are, so that like we can then pick it the discussion from there itself. Like it should be at the beginner level, or it should be like the
Yeah, I got it.
questions or doubts, etc.
Hello,
Hello.
am I audible?
Yeah, you are audible.
Okay, so what's today's topic is KNN, right?
Yeah.
Okay.
Yes, you can discuss on this.
Yeah. I mean,
It would be much better if someone asks any questions, and so that everyone can discuss about that, because I think everyone has gone through lectures, so they might be aware about the basics of KNN, what it
yes.
is, or we can just search about the questions we like.
Okay.
So I was going through. I can share you a chat. I was going through that questions based on KNN. Let me show you. So today morning I shared you a link. Today morning I was going through these questions, and maybe it will be helpful for anyone.
Hello, Bipin, are you sharing anything? Okay, guys, I just wanted to ask one thing.
Yeah.
How are you guys practicing the whole KNN concept? Like, I just want to put a open-ended question because the theory-wise, everything is covered, right? And we basically have a coding assignment there at the end. So what I personally did is I went through some Kaggle data sets and I was basically running the KNN on that. So I just wanted to understand how are you guys algorithm? Anyone actually implemented it?
So basically, if I talk about myself, I just gone through all the videos which sir shared and link IPython notebook so which sir shared and just played around with that. And to be honest, I just implemented that LSH, and apart from that, I didn't try anything else. But I was as sir discussed about FastKNN. So what I came to know that in real life there are some modification like FastKNN. That's how company use them in real life. And the most important, KNN is used for I think data imputation for imputing not null values for some better values rather than from average or median values.
In our course section, there is a revision/interview questions. Can we go through that?
Arun, your voice is cracking a bit, Arun.
Yeah, there's an issue with my earphone. Is it audible now?
Yeah, it's better. Yeah.
Yeah, there's a revision/interview questions on KNN.
Mhm.
So can we go through that? If
Oh yeah, sure, man.
Actually, those questions are from the syllabus only, not from outside.
okay.
Yeah. Anyone is having any idea? I mean, how real time interview questions are? Because when I was searching this interview question based on Canon, it was very simple. I mean, the link which I shared, more or less every link has the same questions and answer, like why Canon is called lazy algorithm, and about scaling, feature scaling, and just Canon can be used for classification only, or you can also use it for regression. This was the common questions on all the website which I was going through. If anyone can find any interesting questions from Canon, please share. Am I audible?
Yes.
So today when I was going through the questions based on Canon, this is just question same the what is Canon algorithm and why it is called non-parametric, what is Canon, K in Canon stand for. So odd value of Canon over even values, and same questions everywhere.
Okay. Why is it called non-parametric? Is it because we are not using any hyperplane? Like,
It's a because uh, Because the data set is not fixed here. I mean, we are not making any assumption about the data set. Remember when we were learning about statics, there were parametric distribution and non-parametric, in which in parametric we made assumption that our data is Gaussian distribution, and based on the given parameter like sigma and mean, we can find the value, probability distribution or anything. But in KNN, if you see, you do not have any fixed kind of data set, or you do not have any parameters through which you can identify or predict any values. There's just only one way to find anything, like to solve the problem like regression or classification. Just find a distance from every our query point to every training data, and that's it. That's why we call it's a non-parametric, because here we don't have any parameter. Parameter you can think of like uh, like in formula. If you try to predict using any formula like I cannot.
I
Yeah, yeah. I mean,
I-
if we look at other algorithms, like there is an optimization problem, right?
So basically, if you try to learn logistic
Exactly.
regression, here we will learn the weight vector W1, W2, W3, Wn, Wd. So that are the parameters. So in next future, you get any value, you can just impute that value with you just impute the find a W transpose XQ, and you got the value. You learn that W transpose W value, no weight vector. You learn that, and you just store in a dictionary. Now, next time you got any query point, you just use that formula W transpose XQ, and you get your value, whether it is positive or it is negative. But in KNN, we don't have such kind of thing. You need to go through each and every data set. Are you getting? I mean, there's no formula. There is
Yes,
no
yes.
fixed way.
Uh-huh.
Right, there is no underlying assumption in KNN, right? That's the
Yeah,
reason why it's not called as non-parametric, right?
We are not learning any parameter here. I hope I am making some sense.
Yes. So are there other algorithms which are not parametric? Which is
Any
popular?
yes, you go on.
No, I was just simply asking, like, are there any other algorithms which are non-parametric? KNN is non-parametric.
Yeah, this is only which I can remember, which I know.
Okay. Okay.
And rest every logistic regression, SVM, decision tree, everyone is parametric, because we are learning there some parameters.
Okay. What about naive Bayes?
Yeah, that's parametric, because we are learning there. Remember, we were solving our goal there was to find a optimal value of W. W is a weight vector. So that's a parameter. We learned that parameter. If we find W, we can in future we get any value of, if we get any query point, we just multiply W transpose XQ, and that's it. We get our value, whether it is positive or it is negative.
Yeah.
So
got
you
it.
can think of W as a parameter.
Yeah, I think decision trees are also non-parametric algorithms.
Yeah, exactly. Yeah, right. Decision tree is parametric.
I just did a small Google search, and KNN decision tree support vector machine is non-parametric.
Support vector machine is non-parametric.
It's from machinelearningmastery.com.
That's a very good website actually too. But
Yes.
we are learning there some parameter.
No. We are actually learning the support vectors, right? But there is optimization problem, so I'm confused.
Yeah, it is saying some more example of popular non-parametric KNN decision tree and support vector machine. I don't know why it is. Anyone knows why support vector machine is non-parametric?
I think is it because of a particular algorithm coming from a particular probability distribution? Does that somehow decide if at all an algorithm is parametric or non parametric? I'm just putting this open question there. So basically, that's how you see parametric statistics and non-parametric statistics, right? So if at all the stats has a probability distribution to it, and we can make some inference, about the distribution using the parameters. That's the reason we call it as a parametric statistic, right? So I'm just trying to connect the dots there between stats and the machine learning. So that is this how we basically decide whether it's a parametric or a non-parametric?
Yeah, I think you're right. In the one article I shared, so it's written there the parametric algorithm assumes some form of like it assumes that some parameters are always present regardless of what the data is. Like in logistic regression, we already know that there will be a weight vector and a bias vector. So these W and V will be always present. So it is written there that whatever if the function, if we assume that the function always has some parameters, then that algorithm is parametric. But in algorithms like KNN and decision tree, that too I'm sure. Also in support vector machines, I don't think we assume anything, right?
Yeah, I have also doubt honestly. But the one thing is about SVM is that it made some advanced optimization algorithm like RBF kernel or something like that. So I also have very doubt on kernel thing.
Yeah, in SVM
But-
also we can map, we can take any dimensional data set, right?
Because as per my knowledge about parametric algorithm is something like we learn something from, like in logistic regression we learn that W weight vector. If we get that weight vector, we can easily calculate whether it is positive or negative. If we get any XQ, thus we need to just multiply W with X and we get our answer.
One good thing that I found here is that the statement is there. A key distinction between parametric and non-parametric algorithms is that parametric algorithms have a fixed number of parameters, while in non-parametric, the number of parameters is dependent upon the amount of the training data.
Yeah.
So, like in support vectors also, right? The number of support vectors are not fixed. They depend on the data. And similar in decision tree, we do not know how much, what the split will be, like how many levels of split will we have. So this looks like a good thing that number of parameters are not fixed here.
Actually, in KNN and decision tree, I am sure, but I'm little bit confused about SVM. Maybe when we'll go through SVM, we can keep it in our mind that.
One thing that's written here is linear SVM is a parametric model.
Yeah, but I just have a doubt by that explanation that if the data size increases, then data size increases and number of parameters, then number of parameters change, then it's non-parametric. But in that case, let's take a regression, linear regression, for example, number of parameters will always depend on the dimensions, right?
Yeah,
More
Yeah,
the dimension, more the weight vectors. So I think that explanation that if the explanation that if parameters increase with the size of data, then that particular model is not parametric. I'm not sure about that explanation.
actually, I think by size of data they mean the number of rows, like n cross d. If we fix the d, then whatever will be the n, the number of dimensions will be always equal to d. So that I think they mean that size of the data means the number of rows.
Okay.
Number of column, I think.
No, rows, right? N cross d. Okay.
Okay. Yeah, I'm not sure what this RBF kernel SVM is. That's what they're saying. Linear SVM is a parametric model, but RBF kernel SVM isn't. That's what.
Yeah, linear SVM is actually similar to logistic regression. What we do W transfer XSC, similar to that. But in RBF, yeah, it's basically a transformation to higher dimensions, similar to that.
Mm.
I think we can ask the same questions in tomorrow's session also, right? Like basically, it will they'll collect some Q&As and we can get it. We can get a solid answer from sir. Just
Yeah,
noting down all these questions. Yeah, so that we can like ask the similar ones in tomorrow's sessions and we can get a foolproof answer from sir. So,
Yeah.
like difference between parametric and non-parametric.
exactly. Yeah.
Correct.
Yeah, and also why SVM is non-parametric.
Why?
Okay. Let me make a note of it.
If we ask about SVM, sir will tell that us when you learn this SVM thing.
Okay, we can at least ask parametric and non-parametric and add that SVM question if sir tells that.
Shall we move the discussion to another topic?
Likit, your voice is breaking a little bit.
We of this plus are also we can discuss other things. Okay, am I clear now?
Yes,
Yeah.
yes.
Okay, let me shoot a question from the revision section. Okay.
Likit, actually, I'm not able to hear your voice. Is it with me or with everyone?
No, everyone.
Your
it is
voice is
breaking for
cutting.
everyone.
It's
Yeah.
written that network bandwidth is low.
John with another John. Hello, yeah. Can you guys hear me?
Yeah, yes.
Okay, great. Yeah.
So I joined a bit late, but I just want to understand like how are we planning this particular meeting? Like how, in the sense when I mean plan, like how are we discussing questions, doubts, or are we presenting something? Are we presenting our understanding? How is it?
So in the group chat, it was decided that if anyone have any doubt, he can ask, or maybe if anyone has some good questions, he can ask.
Okay.
That's what we decided. And even some said that we can even make a whole group revision.
All right. Okay, fine. Yeah, please go ahead.
Yeah, I think if at all we set an agenda, right, that would be more productive.
Yeah.
Rather than us just beating around the bush. If at all we keep a particular
Yes.
concept and focus our discussions on that, right, it will be more productive. Yeah, and
what I also think is that if we move to next chapters like SVM, naive base, we will have more questions. So maybe that session will be more productive, because in Canyon no one can, I think about any questions, because it is very simple and straightforward. Vibal?
Yeah, actually, I had one question. That was a good question that I came across. That
Hmm.
we in KNN we learned that LSH is the best algorithm, right? The
Hmm.
according to the time complexity and all things. So what can be the shortcomings of LSH?
Shortcoming of LSS is that the one thing is that it is probability based. So you're not sure about your answer. It gives certainty about your answer. But if you get a right answer, then your probability of that right answer is very high. But it is not sure that whether your answer is the probability of right or wrong answer is low, based on probability. I mean, it is random because we draw random hyperplanes and we are dividing data set into some, you can say that some area or group. But since the hyperplanes are random, so it is not very much certain. We may not be very much certain about our answer, but most of the time it is correct.
Yeah, but if most of the times our answers are correct, then it's okay, right? What is the with that?
But in KNN, we are drawing the hyperplane, and the
Hmm.
hyperplane is fixed, right, for that model. So when we run the query point again and again, it will be classified like we'll get the same answer again and again, right?
Yeah, because we draw the hyperplane once only. I mean, we can draw it more than one time also, but every time we draw that, what we have decided during our training data set, that will be the same.
If you are using cosine similarity, then I think if the point is close to origin, do we have some limitation?
Sorry, I couldn't get it. Can you please say it once again?
I mean, see, imagine the points are clustered towards origin, and the hyperplane will classify on one side or the other side. But if the point is clustered away from the origin, then there is more likely to be, to be present in one bucket.
Yeah.
Are you getting?
Yeah, this was asked one more time, I think, to the sir, and sir gave answered like we may draw, like example, we draw hyperplane 5 hyperplanes one time, so we can repeat that process for even 2, 3, or 4 times.
Yeah. Okay.
Right. So I think the initial point that Vipin made, that was the only thing that I could come across. That is a stochastic process. So you won't get the same result each time. Like given a fixed set of random hyperplanes, you would get the same result. But if you chose different hyperplanes, then you get a different result each time. So the consistency is not there. So that some can cause issues. The accuracy is there, that is right, but consistency is not there. In all the stochastic algorithms, like also t-SNE and this one, LSH. This one is.
Can you explain like what is the meaning of this word stochastic?
Stochastic means probabilistic or random, which is not consistent. Like if you consider the normal KNN, right? We have some points. We take a query point, we find the distance from each query point, and then do the majority voting and find the output level. So given the same training data set, how many times we repeat the process, we'll get the same answer for the same query point, right?
Okay.
But in the LSH approach, we choose random hyperplanes. Based on that, we do bucketing. So it could so happen that one times the hyperplanes are such that point 1 and 2 fall in the same bucket, but other time they may not fall. So that there is a randomness there. So each on repeating the experiment multiple times, we don't get the same result. That's a stochastic process, random process. That's what
So
I understand.
So stochastic is basically the result changes every time you do the every time you try to predict.
Right, like a
Yeah.
random event, right? We are not sure
Yeah.
of the outcome.
Okay, yeah. So every time you run the model with a query, you get a different answer. That's stochastic.
You can get. We are not sure that we'll get the same answer.
Yeah.
Even I would like to add few points, like for example, in our assignment we were dividing our whole data in 5 hyperplanes. So that means we will have 32 buckets. I mean, every data will fall into that 32 buckets. So for example, if it's not sure that I generated that random hyperplane randomly. So it might be that how many data points are in my bucket may differ from the data points which Bipin generated some 5 random hyperplane and I generated. Bipin may have different bucket in their different data set in their each and every buckets, while I may have different data in my each and every buckets. So that's why it is called stochastic. It is very likely.
But so just imagine a simple case. Let's take 2 dimensions. So we have this x and y coordinate, and let's say that the hyperplanes are x equal to 0 and y equal to 0. So when we classify points, we have first quadrant, second quadrant, third quadrant, and fourth quadrant. And if their point is like 1, 1, and every time it will only check for the first quadrant, right? So the hyperplanes are not changing all the time. So how is it probabilistic? Because the hyperplane is fixed, right? So it will go to that first bucket, which is the first quadrant, and it will check the neighbors. So every time that neighbors will be belonging to the first quadrant, even if we add multiple what do we call that? Multiple hash tables with different hyperplanes, say x equal to y, x equal to minus y. Then also for that particular bucket, it's not random, right? The hyperplanes are not moving every time you execute. So that's my question.
That's the thing, that in the random hyperplane selection is the key part of the LSH. Like for a given set, when we pick the hyperplane, that is like that's not the case. We do it like in a process, but as per if you view the algorithm, the hyperplanes are selected randomly. So if someone did a different random selection of hyperplanes, then the result would differ. That is the case.
Yeah, exactly.
So what is the so yeah, so Arun asked a very good question. So I just want to understand, so the hyperplanes are always generated randomly, like next time it will be different hyperplanes.
Yeah.
Yeah.
Because we are using that np.random.normal, so that is randomly generated.
Yeah, so like why we use that random.normal, and like we can also use random.uniform or something, random dot blah blah blah, or many options are there, but why we specifically use that random.normal?
Yeah, sir said that the geometry of the working of LHS, it works best if we use hyperplanes from normal distribution.
Divya, sorry, can you please come again? Your voice is a bit low.
Yeah. I'm saying that sir said that the working of LSH, it works behind some random projections. The logic is some mathematical random projection. So that works best if we have random normal distribution. So I'm not sure about why it's said, but sir said that in one of the queries.
So can we ask this like again to sir tomorrow?
Yeah, I think it would require a lot of mathematics behind random projection. We can ask that, but maybe that was the case.
So I got your point. You mean to say like sir has given an um, overall conclude like he has concluded that random dot normal is the best to draw the hyperplanes and uh, like that is used as per the like all
Yeah,
the
there is some,
experiments which has been done on the random generations
yeah,
options.
not sure about whether it is an experimental process. It could be there. There must be some logic also, but we don't know the logic. That the random projections is a separate mathematical topic, and maybe from that we are just using the conclusion of that.
Okay.
And one more thing, I think if we draw uniform distribution, like the distribution which we already know, it will create biasness. I mean,
Okay.
yeah. And one more thing, if you want to reduce the randomness, if you want to increase the probability of your model, you can just increase the number of hyperplane. The more number of hyperplane, it will be less random.
Right.
Randomness in the sense like which randomness?
Sorry, randomness. Not, it will increase the probability of your answer.
But
Correctness.
yes, sir. But somehow if we make it the number of hyperplanes is equal to number of the data points, then also like only one data point will be there in one of the bucket. So that also case is like
That's a completely case of overfitting.
overfitting.
Like,
Yes, correct.
yeah,
Correct.
like we use k is equal to n is k is equal to n in kn.
So
Yeah, I think what Vipin meant was, maybe correct me if I'm wrong, that the sets of hyperplanes that we choose, that can be increased. So suppose we choose one set of 5 hyperplanes, and with the problem with cosine similarity is that maybe two like nearby points can fall in different buckets. But if we choose a different set of 5 hyperplanes, then in that case the 2 points can fall in the same bucket. So
Yeah.
that was the thing that Sir mentioned. There was a parameter called L for London. So that can be used to if ensure that two similar points, like close by points, don't fall in the different buckets.
Yeah, completely agree with you.
Divesh, can you like explain once again that point?
Yeah, sure. Maybe I'll share the screen with drawing
Sure.
it. But,
Yeah, that would be better. Thanks.
oh, it's not enabled. Okay. Okay, no issues. I'll explain it as it is. If we assume that in the LSH we take 5 hyperplanes, right? Suppose we choose NS5, and it could so happen that two nearby points can fall in different buckets, right?
Correct.
That was the problem with the cosine similarity and the random hyperplanes, not cosine similarity, random hyperplanes. So what we do is we take another set of 5 random hyperplanes, and then again find the nearest neighbor according to that, and we combine the results of both processes. Set 1 of 5 hyperplanes, set 2 hyperplanes, so that in any one of them, if a point is near to the query point, we'll take them. That was the L parameter, L for London.